Hello there. All right, so last class we finally talked about what a log is and the whole purpose of it. And to refresh your memory, the main purpose of logs is to take an equation when you're trying to get an exponent by itself. You've never learned how to do that until you learned about logarithms. Logs let you isolate exponents. That's the whole point of them. So I'm just going to go ahead and solve this equation because the 6 problem warm-up you had to do, there were no problems where you had to solve for an exponent. And so I wanted to do one before we just jumped into what the notes are today to refresh your memory, okay? This change of base formula that I have up here, this is the thing that you don't need to know unless you have a TI-83 plus and you have to remember how to enter a different log base other than 10 or E. So I'm going to kind of bypass this because I'm going to talk about it here when we solve this equation. So remember, when you are stuck, whether you're solving an exponent equation or you're solving a log equation, when you get to a point where you're stuck, my advice to you is change the form. So I'm solving this equation and I'm stuck, and so I'm going to switch the form of this equation. And again, this is everything we did last class, so this has nothing to do with today's lesson. So I'm going to go ahead and write log. The base of the exponent is the same as the base of the log. A log is an exponent, so I put equals whatever the exponent is, and then I put 25 as the argument, the thing inside the log. Now this is where I don't know what log base 4 of 25 is, but your calculator will tell you. This is where then you take out your calculator and you push math and scroll down to log base and type log base 4 of 25 into your calculator. And when I do that, I end up getting 2.322. To refresh your memory, if you don't have the button that says log base right here, if you don't have that button when you push the math menu, then you are going to have to do this, the change of base formula. So remember, you have to take log of the argument divided by log of the base. So if you don't have that button, you can still do the problem. You just kind of have to remember how to enter that yourself. Okay. So now, in that video I showed last time, the guy kept talking about jumping into the exponential world. When you talk about logs, you are talking about exponents. And when you first learned exponents back in the day, you learned what an exponent was, and then you learned how to simplify problems using exponent rules. You learned when to add exponents, when to multiply them. What do you do if there's a negative exponent? Things like that. Same thing goes with logs. Now that you learned what a log is, there are certain properties, there's going to be 3 in fact, that we learned today, 3 log properties that we can use to simplify log expressions. Very similar to the exponent rules that we've talked about. So I'm going to talk through these 3 properties. These are the 3 you're going to have to know. And then I'll dive down and kind of do some examples on showing you how to use them. Okay, and some things that students do wrong. I'll show you some issues I find students make when using these properties. Okay, so the first property is this. If you have a log of any base, doesn't matter what the base is, and you have a product inside the log, so 2 things being multiplied, you're allowed to take the expression and split it up into 2 separate logs that are being added. So if you have a product inside of a log, you could split this up into 2 separate logs that are being added like this. Now, sometimes the problems are going to say expand, in which case you'd be going like this way. Sometimes the problems are going to say condense. And so these properties all work in both directions. To be quite honest, you have to know how to go in both directions, but the most useful thing you're probably going to be doing is actually going from this direction this way. More than likely, now I'm going to ask you to do both on a quiz or a test. You have to know how to expand and condense. But if you're actually applying log properties to be beneficial, to like solve equations and things like that, it's more beneficial to condense logs into a single log than it is to expand, to be honest. So to kind of look at it this way, if you are adding 2 logs together of the same base, you can merge it. I like to use the word merge. You can merge it into 1 log of that base and multiply the arguments together. So, make sure you're looking at both directions here. But one thing, a misconception that students have is this. So this is wrong, and a lot of students have this thinking. If you had something like this, where you had a sum inside of a log, then these properties don't apply. And this is where some students start to get a little confused. Log is not something that you can distribute. There is absolutely nothing I can do to this expression to expand it or do anything, to be quite honest. Like, I can't distribute the log base a inside of here. So make sure you don't confuse this scenario with this. There's nothing I can do with this. I would just be done if that was given to me as a problem. Well, when you're multiplying inside of a log, you could split it up into addition. When you're dividing inside of a log, you could split it up into subtraction. So if you have a quotient inside of a log, you could split it up into two logs that are being subtracted. And again, it works in both directions. You're more likely going to be taking it from this direction and this way. So if you're subtracting two logs, you can merge it into one log and divide the arguments. The last one is the power property. This one's really cool, and it makes problems a lot easier sometimes. So this one says if you have an exponent inside of a log, like a log base something of something to a power. So if you have an exponent inside of a log, you're actually allowed to take that exponent and pull it out in front of the log. And now it's no longer an exponent, but it's a multiplier. Multiplication is easier than exponentiation. And so this can become very beneficial if you want to look at it in terms of a multiplier. So it'd be n times log base a of u. And again, it works both directions. If I ask you to condense and you have a number in front of a log, then you might take that number and put it up as a power. So it works both ways. So here are your three properties. If you're adding two logs, merge it and multiply the arguments. If you're subtracting two logs, merge it, divide the arguments. And then if you have an exponent, you could pull it out in front. And all these properties work both ways. All right, so let's just do some examples here. So it says expand and simplify the following log expression. Your first instinct is probably to split this up into subtraction. I would encourage you to look and see if anything can be reduced first. When we did exponent rules back in chapter P a long time ago, my advice was simplify any fractions first before applying your properties. I would do the same thing here. I would reduce 9 over 300. You don't have to, but it makes the problem a lot easier. So that's going to be log of 3 over 100. Now I can split this up into two logs. So log 3 that are being subtracted minus log 100. So anytime you have a quotient inside of a log, you could split it up into two logs that are being subtracted. It says expand and simplify. So I expanded it, but now I want to look and see, can I evaluate either of these logs without a calculator? Like, all this work is going to be done without a calculator. Well, I don't know what log 3 is. Remember, if there is no base on a log, then there's a 10 down there. And I don't know 10 to what power gives me 3 without a calculator. But I do know log of 100. This is saying 10 to what power gives me 100. And so this is 2. This log right here is 2. Be careful you don't say 10. A lot of students might look at that and think it's 10, but it's 2. So you have log 3 minus 2. And I can't combine those in any way. Be careful that you don't think that's log of 1. It's log of 3, whatever that is, and then minus 2. Okay, find the value of the following without a calculator. So now I want to know exactly what this value is. And this is really similar to a warm-up problem. On the warm-up, you had to do 4 times ln e to the 5th. That was a problem on the warm-up. Well, we could do this fairly similarly. I'm going to show you how to use this power property to do this problem. So the power property says if you have an exponent inside of a log, you could pull it out in front of the log. So I might look at this and say, okay, pull the 6 out in front, multiply it by the 2 that's already there. So I have 12 ln e, which we'll talk about. And then I could pull the 5 out in front of this one, so minus 5, natural log of e. And this is one you're really going to want to know. You want to know that the natural log of e is 1. You want to know that. And the reason it is, remember, if it's natural log, there's a base e right here that's just not written. So this is basically saying e to what power gives you e, and that's 1. So ln of e is just 1, which means 12 times 1, that's just 12. And then 5 times 1, that's just 5. 12 minus 5 is 7. A common mistake students make, knowing that natural log of e is 1, here's what I find some students do, and this is wrong. They'll look at this right here, and they won't move the 5 out in front. They'll look at it and say, okay, I know natural log of e, they'll say, I know natural log of e is 1, and then 1 to the 5th power is 1. Well, make sure you move that exponent out in front before applying the natural log of e being 1 rule. So just something to think about. I find students do that. Okay. This one says expand. And I want to explain what it means to expand. When the problem says expand, what they want is only one term, whether it be a number, one letter, or whatever the case may be, inside of a log, and they want you to take any exponents out in front of the logs. That's what it means to expand. So at first thought, I'm going to tell you what students do incorrectly. You are not allowed to take this 2 and pull it out in front of the log right away, because this whole expression is not being raised to the 2nd power. So you can't just willy-nilly pull any exponents out in front. The entire argument has to be being raised to that power. So the first thing I notice is that I have a product in here. I have 4 times x squared times y. So I'm actually going to split this up into 3 logs that are being added. So log 4 plus log x squared plus log y. So that's step 1, is I just split it up into 3 logs that are being added. So now notice I only have one term inside of each log, a 4, an x, and a y. And then the last thing I do, now I look for any exponents and pull them out in front. So I would take this 2 and pull it out in front of this middle log. So I have log 4 plus 2 log x plus log y. So that's what it means to expand, is you only want one thing inside of a log and no exponents. So that's fully expanded. Okay. Example 5. So I have natural log of the square root of x squared over y cubed. Now I want to expand this. Now, logs are exponents. So logs and exponents work really well together. Radicals and logs do not work very well together. But we learned in first semester how to change from radical form to exponent form. So my advice is when you're dealing with logs, convert any radicals to exponents. It's going to pay off in the end. So if I'm taking the square root of this expression, I'm just going to rewrite this. Remember, square root means 1/2 power. So now I have natural log of x squared over y cubed, all to the 1/2 power. From here, you have 2 options. You could either pull the 1/2 out in front and then split this up, or you could distribute the 1/2 right here and then split it up. So the choice is yours. I would probably distribute the power personally. So I would write this as natural log of x over, and then multiply these powers, you get y to the 3/2. And I'm expanding, so now anytime you have a quotient inside of a log, you could split it up into 2 logs being subtracted. And then no exponents inside of a log, so take your exponent and pop it out in front of that log. And that is fully expanded. All right. Condensing. So like I said, I wanted to end on this one because this is what you're more likely to be doing when you're using these properties to your advantage, to solve equations like you'll see next time. To be able to evaluate expressions without calculators, sometimes you have to condense expressions first, things like that. So this is very, very beneficial here. So what it means to condense is I want my final answer just to have one log. And I want to perform all the operations to the arguments. Well, if you think back to the last couple, the last thing we do is pull the exponents out in front. So if we're going the other direction, the first thing we'll do is put the exponents back. So the first thing I'm going to do is put this 3 up as a power, the 4 up as a power, and the 4 up as a power. So I have log base 3 of x cubed plus log base 3 of y to the 4th minus log base 3 of z to the 4th. So I just put those numbers back up. Now I notice that these logs are being added, so I can merge that together and multiply these things together. And then I notice this is being subtracted, which means division. So that means I'm going to divide by z to the 4th. So I'm going to show you a couple things. I'll show you the right answer first, and then I'll show you a couple common mistakes students make. So here, this is the correct answer. So I'm going to merge this and multiply x cubed and y to the 4th together. When you're adding 2 logs, you're multiplying the arguments together. When you're subtracting a log, now you're dividing by the argument. So it's important to know where the division goes. All the work is being done inside the argument. So I'm going to be dividing this product by z to the 4th. Like all of that is inside the log. And that would be the final answer. Now here are some things, 2 things students do incorrectly. Most students get the first part right. They'll do log base 3 of x cubed y to the 4th. That's pretty commonly correct. What students see, they're like, oh, I'm subtracting this log, so that means I'm dividing by that log. And they do this, and this is wrong. When you're subtracting a log, you're dividing the arguments. You're not, like subtraction doesn't just magically become division. Like if I'm subtracting this log, I can't just then divide by that log. So all the properties work inside the argument. So not that. And then the other thing students do is they'll multiply these together. And then they'll divide the entire thing by z to the 4th. They'll say, oh, now I'm dividing by z to the 4th and divide the entire expression. This is incorrect as well. Again, all the work is being done inside the argument when you are condensing like this. So that's just a couple common errors. So go ahead and try the assignment. And if you have any questions, let me know. We do have a quiz next time. So make sure that anything you come across that you have confusion on, shoot me an email. See ya.